Yes, can you hear me? So I hope you have enjoyed your question paper of second internal. Right, I'm sure that you have enjoyed your second sessional paper, and in case of some questions like pumping lemma or NFA null to regular expressions to NFA null, right, you have to show the proper steps to get the full marks, otherwise you have an issue. So now today we'll start a very interesting new topic, and that is a push down automata. So I'm sharing a slide with you. So this time definitely I'm not going to directly show you the slides because it is very difficult to understand otherwise. So along with the lecture we'll fill the slides so that you can understand each and every step, because otherwise it will be very difficult for you to understand. So basically in case of finite automata, as we know that we are not using any memory at all, while in case of push down automata we are using a memory, and that is known as a stack memory. And in case of stack we have two operations. The first one is push operation, another is up operation. So when you consider this, we can solve any context free grammar, or we can say languages. Okay, so our goal is we want to handle any context free grammar using push down automata, and we are using a special memory which is known as a stack, which supports two operations, push and pop. So initially when we consider this stack, we are assuming that we have a special symbol which is already given on the stack, and it is known as Z0. Right? This is already on the stack. And now using this push and pop operation, we want to generate a push down automata for the given language. So now for this language L, if you look at this C is a middle symbol. And now for this we have WC, W reverse. If you look at this, we can take W as A. So we have a string like A, C, A. If we take W is equal to B, we have a B, C, B. Then if we take W equal to A, B, we have A, B, C, B, A. Then W is equal to, if we write B, B, it will be B, B, C, B, B. If we take W is equal to B, A, we have a B, A, C, A, B. So this is what we are getting as a set of strings. So if you observe this, it is a middle symbol C, and we want to accept a set of palindromes. We want to accept a set of palindromes with a middle symbol as C. So now when you consider this, what we'll do as a simple example, if we consider, if I want to accept this ACA, right? If I want to accept this ACA, what I will do, I will push symbol A. I will push A on the stack, so it will be like this. This is a new top of the stack. And now once this middle symbol C will come, right, when this middle symbol C will come, we'll ignore that C because it is acting as a middle symbol. So what we'll do, we'll assume that it is the end of push operation. It is the end of push operation. So now what we'll do, when we get the another A, right? When you get this last A, right? What we'll do, we'll pop the A from the stack. Compare with A and we'll generate the message as accept. So what we can observe from this, that if we have a string as ACA, then first we'll push the A on the stack. Then when we get the C, which is a middle symbol, so we'll ignore that middle symbol C. And then when we encounter the last A, when we encounter this last A, so at that time we'll pop the A which is already on the stack, and then we'll compare that A which is on the top of the stack with the last A. Now when both are matching, we'll generate a message that it is accepted. So I hope you are getting this thing, right? So that is how we can work in this push down automata. We have a push operation, we have a pop operation, we have the ignore operation. So now when you consider this, if we take the another example here, right? Let us take the example as ABBA. Let us consider this ABBA, and middle symbol here is C. So this is our actual pattern, A, B, C, B, A. So what will the first step? The first step will be, this is our initial situation of the stack, that is Z0. Now we'll push A, that is this first symbol. Right, so this is what we'll do. We'll push A, and our second step will be, we'll push B. That will be the second step over here. Then the third step will be, when we encounter C, we'll ignore that C. That means we'll neither push it on the stack, we'll not do anything. It will just tell that it is the end of the push operation. It is end of push operation, we can say. Then next, when we get the B, so at that time what we'll do, we'll pop top the stack. So what we'll get? We'll get the B, because now B is on the top of the stack. This is our current situation, right? This is our current situation of the stack. So we'll pop top of the stack, so we'll compare B with top of the stack. Now there is a match. So next we'll consider the symbol as A. This will remove from the stack. This will be removed. Now we have to pop another symbol from the top of the stack. So this is what we'll do now. We'll have a pop again top of the stack. So this top of the stack will compare A with top of the stack symbol. So we are going to compare this A and we are popping this A. So this is our current top of the stack. Now again, so I hope you are getting this. So again both are matching because the last symbol is A and top of the stack is also A. So we are comparing both. As we are comparing both, there is a match. Again we are getting back the original top of the stack, which is the empty stack with Z0 only in it. So we can print the message as accept. Right? So we'll print the message as accept. So you can observe here that how we have done this operation of push and pop. First we'll push the A, then we'll push the B on the stack, then we'll ignore the C, which is indicating the end of the push operation. Right? Then when we get the first B after the middle symbol C, we'll pop the top of the stack. So we are getting B from it. We'll compare that B with the input symbol. Match will be found. Then again we'll proceed further. We'll get the next input symbol. So next input symbol is again A. We'll get the top of the stack. We'll compare both. When both are matching, we'll go for the next symbol. So when the input is over, it is the end of the input, we'll stop the process and we can say our ABC BA is a valid odd length palindrome. Is this flow clear? Any query in this flow? Right? Are you getting this flow? What we have done here? Yes, why 20 is needed? I'm not getting what is 20? What is this 20? What is your query? Okay, it is not 20. It is, yes, Z0. It is a special symbol Z0. Right? It is indicating the first symbol in the stack. It is always there in the stack. Right? It is a default thing. We have a Z0 on the stack. Okay. So now if you observe this thing, here we are able to do this process. The reason is that we know the length of the string, right? The main thing is we know the length of the string. That first AB we have to push on the stack, then C will ignore, and then BA. But in ideal situation, we don't know the entire string because the reason is always there is a capacity of input buffer, right? We cannot have a data more than the input buffer size. So if the length of the string is very large, and if you want to check it is a palindrome or not, we don't know where the middle symbol is, where the middle element is. So that means we don't know the length of the string. Okay, there is one query. How we know when to pop an element, or it is the case after ignoring C? Yes. So this is what Urjit has asked. It is the main thing. That depends from one example to another example. And this logic we have to develop. And this logic we have to develop from one example to another example. It is different. Here it is clear that before C, whatever symbols are there, we'll push it on the stack because C is acting as a middle symbol. Here C is acting as a middle symbol. So all the symbols which are before the C will be pushed on the stack, and all the symbols which are after the C will be popped and compared. So that is how we'll get the matching. But the main thing is how long we should wait for the C, because we know that here C is a middle symbol and we know that it is the end of the we know the total length of the string, but in reality we don't know where the middle symbol will come. The length can be anything, right? That length can be anything. So here if you see that we have various combinations possible like this. If I write this, you can see here we have A, C, A, and here we have A, C, A. So now you can see the difference. Here we have to push this A, right? Then we have C as a pop operation, and this last A, it is for the comparison, and it is for the comparison. Similarly, in this second example, right? In this second example, we have to push these two A's, and when C will come, we'll stop, and when last two A will come, again we'll do the pop operation. Similar to that, if I write this A, B, C, B, A. So here also for A, B, C, B, A, right? For this A, B, C, B, A, right? You will find that when you consider this AB, you have to push this AB, then we have a C, which is a middle symbol, and then we have a BA, will do for the comparison. So here you can see the possible combinations are very less. A can come with A can come with B. Similarly, we have a B, A, C, A, B, 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 C, B, B. So these are the combinations which we have to consider. These are the new combinations we have to consider, that our symbol A can go with A, our symbol A can go with B, our symbol B can go with A, our symbol B can go with B. So you can see that we have one symbol as the top of the stack, another symbol is a input symbol. So now if I want to write the first rule, right, then what we have to do is, we have 4 parameters here, which is very important. To define this PDA, we are writing directly the transition table. Right? So here we have a state number, or let me write a rule number, that will be better. Let me put the word rule. We have a state, we have input, we have a top of the stack, and we have the move. So now this is a very important thing. This is our state transition table, right? We have a rule number, we have a state, we have the current input symbol, we have the top of the stack, and we have the move, right? The move which will perform. So I can write the first rule as, from the state Q0, the initial state, right? Q0 is the initial state. So from the state Q0, on input symbol A, when top of the stack is Z0, we will push the symbol on the stack. This is our first rule. Are you getting this rule? What this rule indicates, that we have a starting state as Q0 of the automata. Our input symbol is A. Now when nothing is there on the stack, we have to push Z0 on it, right? Already. So we have a Q0 as a starting state, A is in the input symbol, and Z0 is on the top of the stack. So what we'll do, we'll push A on the top of the stack. So as a result, we are getting AZ0. What we are getting is AZ0. Right? We are pushing A on the stack. Now, as you can see here, that we have two possibilities. It is not necessary that it is always ACA. If it is ACA, right, it is true that we have already Z0 on the stack and we are pushing A, right? If it is ACA, it is true that A is in the input, Z0 is on the top of the stack, we are pushing A on the stack. Now, if the string is this, BCB, if the string is BCB, then what we'll write? We require a different rule because our rule will not work, right? Our rule will not work. If the first symbol is B, middle symbol is C and B. So now, to handle this BCB string, which is also a valid string, we need another rule. So for that purpose, we'll write a separate rule like this. Our state is Q0, input is B, top of the stack is Z0, it is Q0, then BZ0. It is BZ0. So you can see here, right? It is Q0, BZ0. So now What this tells us that these both rules are not applicable. These both rules are not applicable. Any one rule is applicable at a time. If your string which you want to validate will start with A, you will use the rule number 1. You will use the rule number 1. If your string starts with B, you will apply rule number 2. So these are two different rules. Only one of them is applicable. If your input starts with A, rule 1 will be applied. You will push A on the stack. So on the stack we have two things, the previous stack and the new stack, right? Previous top of the stack and the new top of the stack. You don't have any another information. In the stack you cannot see any another extra information. What you can see the previous top of the stack. You can see the modification in the top of the stack. The content below the top of the stack is not visible to you. Any content which is below the top of the stack is not visible to you. Clear? So these are the two different rules which are available with us. We have to apply either rule number 1 or we have to apply rule number 2, any one of them. Now if you consider the other possibilities, right? If you consider the other possibilities, we have to think about the second rule. We have to think about the second rule. So now what is the second rule? Because we don't know which string user will enter. We don't know which string a user will enter, right? So for that purpose, we need to think, right? If the string is this, let us consider the string is AACAA. If this is a string AACAA, so now what will happen? That for the first A, we'll apply rule number 1. We'll apply rule number 1 and we'll push A on the stack. Now you can see we cannot apply rule number 1 because our new top of the stack is A. Our new top of the stack is A now. After pushing the first A on the stack, now our new top of the stack is A. So you cannot apply rule number 1. Rule number 1 is only applicable when top of the stack is Z0. When top of the stack is Z0. So we need a separate rule that still it is a push operation. Q0 is indicating here a push operation. So still we have to do a push operation. Okay. There is a query that what is Q0 comma AZ0. So here we have a Q0 that is a initial state which is the push operation, and then we have a AZ0. So that AZ0 means what? We are pushing A on the top of the stack. So Q0 means still we are having a push operation because we are not changing the state, right? We are not changing the state. So still Q0 is a push operation. AZ0, that means now we are pushing A from the input to the stack. Okay, so now this rule is not applicable when it is AACAA, right? When the input is AACAA, how to handle the second A? Right now we are discussing that part. That when the second A will come, can we apply rule number 1? So the answer is no. When the second A from the input will come, right? We don't know the whole input. Always keep in your mind that we don't know the input. We know only one character at a time. We know only one character at a time. It is just like that two friends are playing a game, right? You have a stack, another friend is giving you one by one characters, right? Think that two players are playing this game. One player is having a stack with Z0 on it, and second player is giving one by one alphabets, only one alphabet at a time. So now what you have to do? You know the rule which you have defined. Yeah, you are clever enough so that you have defined a rule to recognize the odd length palindrome, right? The game is odd length palindrome. So what you are doing, you have a stack and you have defined a rule that when the C will come, I will push all the symbols one by one. When C will come, I will push all the symbols one by one, and after that I will start popping the symbols. So here what we'll do, when the second A will come, clear? rule 1 is not applicable, because rule 1 is applicable when top of the stack is Z0. So now what we'll do for the second A, we have to write a rule such that we have to do the push operation. Input is A, definitely. Top of the stack is also A at that time, right? So we can write like this. Q0 input is A, top of the stack is also A. Now what is the rule of the game? That we have to push all the symbols until C will come, right? We have to push all the symbols until C will come. So now what we have to do? We'll write a rule as Q0, still it is a push operation, AA. It is Q0 AA. The reason is that we are pushing the second A, still it is not a power operation. Still we have not received the C symbol. So it is still a push operation, right? We cannot do power operation. So when the second A will come, still we have to preserve that second A. Still we have to preserve that second A. So that's why what we'll do, we'll push that A on the previous top of the stack. We are pushing the A on the previous top of the stack. We don't know any symbol below the top of the stack. Clear? We don't know any symbol below the top of the stack. So the previous symbol on the top of the stack is A. The new symbol on the top of the stack is also A. So it is Q0AA. It is Q0AA. Is this clear? Okay, now let me show you that here if we do this, it will work for this kind of examples. It will work for this kind of examples. Now let me tell you, if this is my string, what we will do. Okay, if you can give the answer. Okay, let us consider that my string is, suppose this A, C, A. Now what we'll do? Do we need any extra rule? Which rule we can apply? For the first A, not only 3. Yes, the correct answer is rule 1 and rule 3 both. We need both the rules, right? Because we have to push A first. So here it is rule 1. Here we will apply rule number 3. And again, we have a rule. We'll apply rule number 3. So now you can see that we are applying rule 1, we are applying rule 3 2 times, right? Because still rule number 3 is applicable. When we can apply the rule 3? When input is also A, top of the stack is also A. When both are A, we can apply the rule number 3, and it is a push operation. We are not changing the operation here. If we are changing the operation, this rule is not applicable. This rule is not applicable. Okay, so I hope you got the point that our game is like this, that one student having a stack, and the rule is it will push all the symbols on the stack one by one, which his friend will give him, and when C will come, he will stop the push operation. He will stop the push operation. That is the rule of the game. So now, if the string is different, not this one, let us change the string as BAC, and let us take the string as, let us take this ABCBA. So now can you tell which rule is applicable? Yes, can you tell which rule is applicable now? Right, this is your new string. Suppose you want to recognize this ABCBA. Out of these 3 rules, which rule is applicable? Or can we apply any rule? Yes, we can apply the first rule. The reason is, why? Because our top of the stack is Z0. Our top of the stack is Z0. Input is A. So we can apply the rule 1 and we can still push A on the stack. So here I will push A on the stack by using rule number 1. By using rule number 1, I am able to push A on the stack. Now the next is my input is B. My input is B, and I want to apply the rule. So which rule I can apply? Now my top of the stack is A and input is B. Clear? Now my top of the stack is A and input is B. So which rule we can apply? Okay, so what we should do now? Yes, this is what Yash has written. We have to do the same thing, right? We have to do the same thing, right? So we'll write a rule. Q0 input is B, top of the stack is A, Q0 B A. So I hope you got the point now. That will apply this, and it is rule number 4. As per the rule number 4, we are pushing B on the stack. And keep in your mind that you know only the previous top of the stack and the current top of the stack. You don't have any other information. These are the rules, right? These are the rules we are writing, which is applicable to any example, right? We are writing the rules or we are generating the rules which are applicable to any example. Okay, now let us consider another example, and then you have to give me the answer. Let us consider this. If you want to solve this kind of example, what we'll do? Okay, now we want to solve this example. So what rules will apply? Okay, so the first is we'll apply rule number 2. Because B is in the input, Z0 is on the top of the stack. So as per rule number 2, we are able to push B on the stack. Now our next requirement is what? Our input symbol is A. Our input symbol is A, and top of the stack is B. Our input is A and top of the stack is B. So yes, we have to add one more rule, like what Yash and Urjit has said. We'll write that rule as, let us add the rule number 5, Q0 AB so we are able to push A on the stack. As per rule number 5. Okay, now let us consider further. If we have a pattern, which is the last pattern we should check now? Which is the last pattern we should check now? Yes. So you know that pattern, B, B, C, B, B. So definitely we'll add that rule directly, as you know everything now. It is Q0BB. So now you can see that rule number 1 will be applied 1 or 2. Rule 1 or 2 will be applied only once, while rule number 3, 4, 5, 6 are recursive rules, and that can be applied any number of times for the push operation. Clear? This rule number 3, 4, 5, 6 can be applied any number of times. We can apply these rules any number of times, 3, 4, 5, 6 for the push operation. So now we have defined all the rules for push operation. So now let us focus on this pattern one more time. Right, let us take this pattern ACA. So as we know, it is Z0. We are pushing A as per rule number 1. So this is done. Now what will happen? Now when the C will come, you can see the next input symbol is C. The next input symbol is C. So now when C will come, we have to tell that we have to stop the push operation. So when we want to stop the push operation, that means these rules of Q0 should not be applied now, right? We should stop that we cannot apply these rules from 1 to 6. We want to stop the push operation. And also C is acting as a middle symbol. So C will not be pushed on the stack. C will not be pushed on the stack. So what I will write? I will write as rule number 7, Q0 when input is C, top of the stack is A, we'll write Q1. I'm writing Q1 and here A. So can anyone give why we are writing like this? Can anyone give the reason? Right? Can anyone give the reason why we are writing like this? That what this rule tells, that it is the end of the push operation. Right? It is the end of the push operation. So we are moving from state Q0 to Q1. We are moving from Q0 to Q1 state. Now we are not pushing C on the stack. We are not pushing C on the stack. So because of that, we are having a no change in the top of the stack. Top of the stack is as it is. It is as it is. But the state will change from Q0 to Q1. The state will change from Q0 to Q1. Okay, now, so if this is a string, we can do like this. But if the string is this, B, C, B, right? If we have this string, what we'll do? We'll apply rule number 2. We'll push B on the stack. Okay, there is one query. Why it is A or AZ0? It is A because you can only see the top of the stack. Right? You can see only the top of the stack. So what is the top of the stack? It is only A. We don't know what is the symbol below it. We don't know the symbol below it. It is not necessary that it is AZ0. It can be AA also. It can be AA also. We don't know the string. We know the current symbol. Right? This is a very crucial thing that we are defining the rules. So what we know the current top of the stack. Right? It can be anything. Okay, let me give you another example. I think this will clarify the thing. If we write like this, AAC, AA. So now what will happen? We'll apply this to right? We have this AA. So when the C will come, right? You are ignoring the C. You are ignoring the C, but you don't know whether it is AZ0 or double AZ0. You don't know. I hope it is clear, Yash. Right? Right? So that's why we are writing only this. That what is the current top of the stack? We know it is A, so it is A as it is. We don't know anything below it. Right? We never know what are the symbols on the stack. Okay, so now let us proceed with this. If this is our example, B, C, B, what we'll do? Right? First B will push it on the stack. The first B will push it on the stack. Now after that, as per rule number 2, and then when the C will come, can we apply rule number 8? Can we apply rule number 7? Yes, can we apply rule number 7? No. So what we have to do, we need a separate rule for that. So we have a rule like rule number 8. We have a Q0, C, B, Q1, B. It is Q1B. Right? Q0, CB, it is Q1B. So we are able to handle this C also. It is the end of the push operation, and now we can do the pop operation. So I hope up to this point it is clear. Up to this 8, it is clear. No query in this. Right? So now let me write the new rules for the other examples. We have a state, here we have a input, we have a top of the stack, and we have the move, and we have a rule number. So let me write down rule number 10. Okay, let us take this example. So we have done push operation, We have done ignore operation, right? We have done this as per rule 1. We are able to push this A. Then we have ignored this. Right? We have ignored this C. Now what we need to do? Right? Now what we'll do? We have to do the pop operation. We have to do the pop operation. So now in rule number 10, we'll write what will be our state? What will be our state? Q0 or Q1? It is Q1. It is Q1, right? Because now we are doing the push operation, pop operation. So Q1, input is A, top of the stack is also A. So now we want to apply this pop rule many times. We want to apply this pop rule several times. So it is again a Q1. We are not changing the state. Okay, now here the main thing. We are popping the symbol from the top of the stack. We are popping the symbol from the top of the stack. We don't know the whole example. Right? We don't know the whole example. It can be like this also. Right? We don't know anything. We are having an input symbol A and we are having a top of the stack as A. So it is like this. This right is what we have. So you can see that so now when input is A, top of the stack is also A. When input is A, top of the stack is also A. We'll do the pop operation. We'll pop the symbol from the top of the stack. We'll compare with the current input. We'll compare it with the current input. And if it is matching, it is fine. We can proceed further. So here you can see that top of the stack will match with the current input symbol. Right? It will match with the current input symbol. So now what we'll write? That we are popping the A from the stack. Still we are doing the pop operation. But the symbol below the top of the stack. Do we know that symbol? We know only the top of the stack, which we are already popping. Right? We know the top of the stack, which we are already popping. Clear? So we don't know the symbol below the top of the stack. So what we'll write? That we'll write here as null. Right? We'll show null. Null means we don't know. There is some symbol when we are popping this A, but we don't know. Is this clear? Right? Is this pop operation clear? Okay. So now this is applicable when input is A, top of the stack is also A. When both will match, we have this rule applicable. Okay. Now, if the input is B, top of the stack is also B, we'll write again Q1 null. Right? When input is B, top of the stack is B, we'll write Q1 null. The reason is we have to match input B with the top of the stack B. Right? We'll match input B with the top of the stack B. So now when we'll do this matching, and if everything is matched, A is matched with A, B is matched with B, what will be left in the input at last? If you check every element after C, what will be left in the input? In the input. Yes, in the input it is null. In the input it is null symbol. Right? So we need a rule. We need a rule for that. We need a rule for that. that once you go through this all pop operations, if A will match with A, B will match with B, at last you will get Q1 input is null. Okay, when everything is matched, what is left on the stack? What will be left in the stack? Yes, it is a Z0. It is Z0. So we have a Z0. So we'll write Q2Z0. We'll write Q2Z0, where Q2 is the right. This Q2 is the accepting state. It is Q2Z0, where Q2 is the accepting state. That we reach to the accepting state. So what is the criteria for accepting here? That it should be the accepting state, and you must have consumed the whole input. You must have consumed the whole input. If you have not consumed the whole input, you cannot declare whether the string is valid or not. If you have not consumed entire input, you cannot tell it is a valid input. So what is the criteria? That in case of finite automata, it is only accepting state. In case of finite automata, it is only accepting state. But in case of push down automata, we have two main criteria. The one criteria is that we have to consume the whole input, full input, and the state must be an accepting state. The state must be an accepting state. So now let me tell that what will happen in this case. If the string is only this, suppose you want to check for this, is it valid or not? Yes, is this valid or not? This is our language. Is the string C valid or not? Yes, is it a valid string? Should we accept C? Yes. So that means if directly if your friend will give you C, right? If your friend will give you C, right? Then we need a rule for that. We need a rule for that, and that will write as rule number 9. That will write as rule number 9 here. Q0 C Z0. It is clear? We are writing a rule Q0 C Z0. This is the rule number 9. Right? In the previous slide, we have gone through 8 rules. In the previous slide, we have gone through 8 rules. Now we are adding a rule number 9, Q0 C Z0. That if the input state is Q0, push operation, C is the input, top of the stack is Z0. What we have to do is we have to write the rule as Q1 Z0. We'll write the rule as Q1 Z0. So can you tell why we are writing Q1 Z0? Why we are writing Q1 Z0 and not Q2 Z0? Why we are writing the rule as Q1 Z0 and not Q2 Z0? Because it is also a valid string. Why we are not writing this Q2 Z0? Yes. So whatever Priyank has written, after C, there can be another symbol, right? If someone will give you invalid input, like this, right? If the input is this, suppose we want to check for this input. Let us have the input as Let us consider input as CA. So now what will happen? It is Z0. Now if it is CA, right? It is CA, so we'll ignore this C. We'll ignore this. We'll ignore this C. So as per rule number 9, we are here. We'll apply rule number 9. Q0 C Z0, it is Q1 Z0. So now our state is a Q1 state. Now our state is a Q1 state. So now from the Q1 state on input A, right, we'll check for the rule from the Q1 state, which is a pop state or pop operation. We'll check for the input A and we'll check for the top of the stack Z0. We'll check for the top of the stack as Z0. So do we have any such rule? Do we have any rule like this? That is Q1 A Z0. Do we have a rule like this? No, because Q1 is the pop operation, A is the input, and top of the stack is Z0. So do we have a rule like this? No. So the system will crash and we can say string not accepted. So this string is not accepted, right? So I hope now you got this thing, that why we are writing this. So CA is not accepted. This CA is not accepted. Is it clear? Okay, now let me write one more string. Okay, if we have a string this A, B, C, B, B, what will be the set of moves? Okay, but sir, we are always checking the stack for push and pop. So our rule should be Q0 null Z0. Okay, Q0 null Z0, it cannot be checked here because the actual language is WCW reverse. So here we don't have to check for null, right? Either it will be A, B or C, any one symbol will be there. So you don't have to check here for null. In rule 9 instead of C, no, in rule 9 we have to check for C. The reason is when the input is C, it is a very special case. If someone will enter only C, because C is a valid string, right? So only in that case we have to check if the input is C and top of the stack is Z0, we have to apply this rule Q1 Z0. Rule 1 is not applicable, rule 2 is not applicable. We will apply only rule number 9 for this string, for the string CA, right? Because rule 1 is not applicable, rule 2 is also not applicable, right? These rules are not applicable. 1, 2, none of them are applicable. They are applicable when input is A or B. 3, 4, 5, 6 are applicable when we have a push operation. 7 and 8 are the ignore operations. Right? So here only rule number 9 is applicable. Okay, so can you tell the sequence of rules for this? A, B, C, B, B. The first will apply A. When you apply A, you will get Q0, AZ0. Right? When you apply rule number 1. When you apply rule number 4, you will get Q0, BAZ0. Right? Right? I'm applying a rule. Right? I'm applying a rule, so I know the whole thing. This is, we are applying a rule to the example. Now what we are doing, we are applying the rule to the example. So our example is A, B, C, B, B. So when I apply rule number 1, I have Q0, AZ0. When I apply rule number 4, it will be Q0, BAZ0. As you can see here, we are pushing B on the stack. Right? We are pushing B on the stack. Now it is C. So C and B. So we are applying rule number 8. Right? C and B. So we are applying rule number 8. So we are getting Q1 BAZ0. We are getting Q1 BAZ0 as per rule number 8. We are not pushing C. We are ignoring it, but we are changing the state. Now it is Q1 BB. Right? As per rule 11. So Q1 AZ0 because we are cancelling the input B with the top of the stack B. We are cancelling the input B with the top of the stack B. Now Q1 AZ0 on the with us and input is B. So which rule is applicable? Which rule is applicable? We'll apply rule number 12. We'll apply rule number 12 because what is our state? Q1. Our state is Q1. What is the input? Our input is B, right? But B is not there. But in rule number 12, input is null. So we will consider null. We'll consider null. We'll consider null and top of the stack we'll check. What is our top of the stack? It is what is our top of the stack left? A. Is it clear? Our top of the stack left is A. So what we require? We require this kind of thing. We require this kind of thing. Q1, then null, and then we need A. We require this kind of rule. But it is not there. So basically here we cannot apply even rule 12. Is it clear? We cannot even apply rule 12. The reason is even though it is Q1, null is there, but top of the stack is not Z0. Top of the stack is not Z0. Top of the stack is A. Is it clear? If you consider null, then also we cannot apply that rule. Because in the rule number 12, input is null, but top of the stack is Z0. While in our case, top of the stack is AZ0. In our case, right? So in our case, top of the stack is still A. So Q1 is there, null is also there, input null is there. Right? Our state is Q1, input is null, or we can say B, both we can check, and top of the stack is A. So there is no such rule, right? Also we can check for this, input is B. Is it clear? We can check for both. We have to check both the inputs. State is Q1, input is B, top of the stack is A. So there is no such rule. State is Q1, input is null, top of the stack is A. So it is also not there. So it will crash and string is not valid. Is this clear? Any query in this? Now what will happen in this case? Can you tell? If we take this example, BBC, BB, can you tell the set of rules? Can you tell the set of rules? Yes, can you recognize the set of rules for this? Yes, first is 2, then 6 and 6 for push operation, then 8 for ignore, then BB, so 2 times 11, then 12. So it is accepted. Is 12 required? Do we get 12? Yes, 12 is also applicable. Yes, 12 is also applicable. Because once you pop the 2B, what is the input? It is null. So Q1 null. And top of the stack is Z0. So it is not applicable. Rule 12 is not applicable. Right? Because still we have one more B on the stack. Still we have one more B on the stack. Our top of the stack will be B. Our TOS is B. We are able to pop only 2. Right? Yes. What Priyank has written is correct. When it is BBC, BBB, it is correct. Right? First push will 2B, then C ignore, again pop the 2B. Still we have 1B left in the input. So we'll consider null at that time, Q1 null. Okay, so we'll see more about this in the next session. Right? Still the example is not complete. We'll take the example and we'll trace it further. So here I am ending this session.